So, have you ever looked at the map of the world and noticed how the coastlines of South America and the Africa look like they could fit together? This jigsaw puzzle fit was first clue to a revolutionary idea. While the early scientists like Alfred Wegener talked about the continental drift, it was the theory of plate tectonic in 1967 that finally explained how and why behind the movement of the earth. So, what exactly a plate? In geography, a tectonic plate or a lithospheric plate. So, let's get started with this. So, in geography, a tectonic plate or a lithospheric plate is a massive, irregular, and irregularly shaped slab of solid rock. It is important to remember that a plate consists of the entire lithosphere, which includes the crust and the topmost solid mantle as well. This okay, just let's these plates these plates float on a semi-fluid jelly-like layer called the asthenosphere. So this is the layer of asthenosphere. We categorize them into major plates like the massive African or Pacific plate and minor plates such as Nazca, Arabian plates. Think of these plates as giant sheets of ice floating on a lake, constantly moving, colliding, and shifting. The most There are three types of plate boundaries. The most dynamic action happens at the edges of plates. At the edges of plates or the plate boundaries. There are three ways these plates interact. First is divergent plate boundaries. So this is the divergent plate boundary. Here, plates pull away from each other. As they separate, magma rises from the mantle to create new crust. The best example is mid-Atlantic ridge. Next is convergent plate boundaries. This is where the plates collide. Usually the denser plate sinks beneath and the lighter one in a process the denser plate sinks beneath the lighter plates, and this process is called subduction. This is how the Himalayas were formed, by the collision of Indian plate and Eurasian plates. So next point is transform plate boundaries. Here the plates simply slide horizontally past each other. No new crust is created or destroyed, but the friction causes massive earthquakes. The San Andreas fault is a classic example of this. Now, okay, just wait for a while. Now, the big question, what is the engine driving these massive plates? What is the engine? As proposed by Arthur Holmes, the answer lies in mantle convection. This is mantle convection. Inside the earth, heat generated from the radioactive decay creates convective cells. These are convective cells. And hot magma rises, cools, and then sinks it again. So this provides that the earth is not a static rock but a living, breathing, and recycling system. So, to conclude the plate tectonic theory, the plate tectonics is the grand unified theory of the earth science. It explains the birth of mountains, the widening of oceans, and the occurrence of earthquakes and volcanoes. It teaches us that our planet's surface is a state of constant recycling. Thank you for your time. Now, I'm open to any questions if asked in the interview panel from this chapter. So, if the interview panel asks us one question from this chapter, how does plate tectonics differ fundamentally from continental drift? So we can answer like this, that continental drift theory suggested that continents moved through the oceans. Only the continent moves through the continent moves through the oceans. Plate tectonics suggests that the entire lithosphere, crust plus upper mantle, moves as plates. Next question, question number 2. Who were the scientists responsible for the plate tectonics theory? So, while Wegener provided the base, the theory was formally coordinated by Mackenzie, Parker, and Morgan in 1967. So, plate tectonics theory was proposed by Mackenzie, Parker, and Morgan in 1967. Next, question number 3. What is the lithosphere composed of in this context? So, the lithosphere includes the crust or the topmost solid and the topmost solid mantle. Its thickness varied from 5 to 100 km in oceans and 200 km in continents. So the next question, why is the Pacific plate unique among the major plates? So the Pacific plate it is the only major plate that is almost entirely oceanic. Pacific plate is entirely oceanic. Okay. And in composition, making it denser and prone to subduction. So Pacific plate is prone to subduction. Next, explain the concept of seafloor spreading. So what is seafloor spreading? This theory was proposed by Harry Hess. So in 1961 by Harry Hess. Harry Hess. So it states that new oceanic crust is formed at the mid-oceanic ridges. This is the mid-oceanic ridges. So here the new oceanic crust is formed and spread outwards. The younger rocks found the ridge crest. These rocks are younger, and these further from this, these rocks are older. Next question: if the seafloor is spreading, why is not the earth expanding? So because while the new crust is created, while the new crust is so here new crust is created at divergent boundaries, old crust is destroyed by sinking into the mantle at subduction zone. So this part is being destroyed by sinking into the mantle. Next question, what is subduction zone? So next question, what is subduction zone? So it is a boundary where the denser plate, usually this denser plate is oceanic, usually it is oceanic, sinks beneath a lighter plate or continental plate into the asthenosphere. So next question, why are the earthquakes frequent at plate boundaries? So this area is a earthquake prone zone. So just wait for a while. So this area just so this area, the plate boundary, this area is frequent earthquake and volcanoes are found here because the movement of plate is not smooth. This movement is not smooth. They get locked due to friction. Here the plate is locked due to friction. When the stress overcomes friction, when the stress overcomes frictions, energy is released as earthquake or volcanoes. Next question, describe the Pacific Ring of Fire. So this region is a Pacific Ring of Fire region. It is a horseshoe shaped zone of intense volcanic activities found in this region and seismic activity caused by subduction of several oceanic plates. Subduction of several oceanic plates. Next question, how were the Himalayas formed according to this theory? So Himalaya was Himalayas were formed due to continent convergent. So this plate is Eurasian plate, Indo-Australian plate. Both are continental plate which squeezed the sediments. In this region, the sediments were squeezed due to collision. The squeezed the sediments of the Tethys Sea. This region was Tethys Sea. It transformed into mountain due to collision. Next question: what happens during the oceanic convergence? If the both so if the both plate is convergent plate, what happens? So the older and denser plate subducts. This is the older and denser plate. It subducts and forming island arcs and deep oceanic trenches. Here the island arc and deep oceanic trenches are formed. For example, the Japan island arc. Next question: what is the significance of mid-Atlantic ridge? So if this region is mid-Atlantic ridge, what is the significance of this region? So this is a classic example of divergent plate boundaries. This is a classic example of this region, mid-Atlantic ridge, divergent. Both plates are push away from each other. Where the seafloor is actively spreading, creating a volcanic ridge on the ocean floor. So next question: how do the transform faults differ from the other two? This is a transform fault. So how it differs from the other two plates? Unlike other transform faults involve horizontal sliding. So lateral or horizontal sliding is found in case of transform faults. There is no vertical movement or volcanic activity here. No volcanic activity here. Next question: what is paleomagnetism? What is paleomagnetism? And how does it supports this theory? So paleomagnetism is the study of Earth's magnetic field. Paleomagnetism is the study of Earth's magnetic field. Study of Earth's magnetic field. The study of Earth's magnetic field that preserved in rocks. Symmetrical magnetic strips on either side of ocean ridge. There is their symmetry is found on either side of oceanic ridges, prove the seafloor spreading. Next question: explain the convection current theory. So what is convection current theory? So just wait for a while. Okay. So Arthur Holmes proposed that thermal convection in the mantle, driven by radioactive heat, that acts as the engine that moves the oceanic plates. So this is the region of asthenosphere or convective current cell. So these are the plates, and it moves due to the convection cell creates in this region. So next question, what are hotspots in plate tectonics? So what are hotspots in plate tectonics? So hotspots are volcanic region. So what is hotspot? So hotspots are the volcanic regions fed by underlying mantle plume that are independent of plate boundaries. Just for example, the Hawaiian island. So next question, what is Panthalassa? So let's get started with Panthalassa. Okay. So just it what is Panthalassa? It was a mega ocean that surrounded the supercontinent Pangaea. Before it broken into different parts. So the next question, how we measure the rate of plate movement today? So scientists use GPS, satellites and space geodesy to measure the movement in millimeters or centimeters per year. The next question, which plate is moving the fastest? So the East Pacific rise, this region. The East Pacific rise near the Easter Island has the fastest rate. This region has the fastest rate, moving more than 15 centimeter per year. So today's last question is, what is the future of Earth's plates? So plate motion is continuous. In millions of years, the Atlantic will widen, Pacific will shrink, and a new supercontinent naming Rodinia may eventually form. So thank you for listening. Keep listening for the further videos. Thank you.